Hello, everyone. Oh, good. Just wanted to check, make sure my microphone was working. Welcome, and I see somebody. Hey, good morning, Walter. Yeah, look at that. You're right on time. Yeah, we're going to talk about using detectors with an Arduino Uno. And you don't get to see my face because I need to get better I need to get a better presentation camera for doing the boards. This is my regular webcam that I normally use when I'm gaming, and it's a little limited as far as what I can do with it. I don't have the zooming and everything that I'd like to have. But that's beside the point. So let's talk about using detectors. So there's many different types of detectors usable, and what I'm showing here is a basic Arduino Uno and a breadboard beside it that we're going to use to mount a lot of our parts onto. So I'm just going to show you what a couple of the different components look like that you might be familiar with when we're talking about detectors. And the first one is this little guy here, which I'll tell you right now is going to be hard to see. It's probably not going to be in the best of focus, so let me just see if I can adjust that a little bit. Right there. It's got that little wavy front on it. Not very big to see, but it's there. Yeah, you know what? I might need a document camera. I'm actually going to look for a proper presentation camera. I think I found one. I don't know how long it'll take to get here, but we'll see. I found one on Amazon that I think I might give a try. But this little device here is referred to as an LDR. An LDR is a light-dependent resistor. So what happens here is that as you shine light onto it, the resistance changes. And that we're going to use, and we're going to read those numbers in, and we're going to utilize those to turn on and off a couple of LEDs that we're going to install. The second type of detector I'm going to use is something that looks like this. And these are nothing more than a couple of little LEDs. So we can see one here is black, and the other one is clear, got a clear shell on it. Now the clear shell is actually the emitter, and what that's going to emit is light, but in the infrared spectrum. So we can't see it, but this detector that looks like it's solid black will actually, it filters out everything but infrared. So it's going to actually see the infrared signal, and we're going to be able to utilize that. And just as a third type we're going to show is an encapsulated detector, which looks like this. Now the beauty of this thing is it's already mounted in a frame. This one happens to be, and we'll just show it there, that one happens to be the detector, and you can see that it's a black LED on there. It's also got 3 wires connected to it, and we'll explain those when it comes time. And at the other end we have this one here, and it has a clear LED just like the other one was the emitter, and that is the one that's going to be the one that's the light source. So it just has a red and a black. Now the beauty with these things is these are already set up for 5 volts, which is 3.3 to 5 volts, so they're good for any of the microcontroller boards. And they already have all the resistors and everything in them that you need to work with them, which makes it really, really easy. And I'll show you how we can do something different with those compared to the other ones. So just to start this out, I have a circuit running here, and I know what's on this board, but assuming you don't know or it's a brand new board, we're going to start out by setting up a little bit of a sketch. So let me see if I could focus that board in a little bit. Not that you can see a lot on it, but it's there, and we're going to work with this document here. First thing I like to do is I like to put a title in something. So I'm going to go ahead and I'm just going to fill that in while we work here. So we start with a comment, which is nothing more than a double slash. And I'm going to put in here just the title of this little thing here. So using detectors with an Arduino Uno. And I'm going to add me as the author since this is my little file here. So I'm just going to say it's by me, put it in there. And now I'm going to create this file. So one of the first things we do with this is we always go up here to File, and the first time we go to save it, we save as. And the reason for that is because it starts with a default name like this. It says sketch-LD APR11A, which stands for April the 11th. And it's A because it's the first instance of this I'm using today. So what we're going to do here is I'm just going to turn around and I'm going to go File, Save As, and I'm going to set it up. And you won't be able to see this in here, but I'm basically going into my Arduino folder that I have, and I'm going to create a folder, and I'm going to create a new folder, and I'm going to save it as, for the file name, just, what is it? Detectors. And if I could spell, we'd be all right. Okay, detectors. That's all I'm going to save it as, and I'm going to say save. Now, once I've saved it, it changes the name in here, and it tells me that I'm working with a new file called detectors, which is really, really handy. And now I'm going to keep it straight, and that way, the big thing with saving right away when you make your first change to a new file, or you're going in and editing another file, but you don't want to get rid of the old one, if you go save as, you can save a new copy of it that is not going to interfere or overwrite your old work. So we always want to make sure of that. So the first thing we want to do on here is we're going to make sure we can communicate to this. So I'm going to go up here to Tools. I'm going to make sure that I'm connected to the board, which is an Arduino Uno. And I'm going to go to my COM ports, and it tells me that COM10 is my Arduino Uno. It's actually recognizing the board. So we're going to go ahead and save it there. And to save this, all I'm going to do is I'm going to come up here. I'm going to verify. There's really nothing done on this, so it should compile just fine. And it should say yes, and it should basically come up with no errors down here at the bottom. And it did. It didn't come up with any orange warning bars or red warning bars, so we're good. Now I'm going to upload that to the board. On the board, there's a couple of lights there that'll flicker for a moment, and that's just communicating with the board. And it has now been saved. So now I have basically an empty board to work with. I have it free, ready to go. And it's a nice starting place. So what I'm going to do is I'm going to hook up a couple of LEDs because we're going to use a couple of LEDs to start this thing. And this is pretty straightforward. So a couple of things I'm going to do is I'm going to take two jumpers here, a red and a black. I'm going to connect my black to ground. I'm going to connect my red to my 5 volts. And I'm going to just use that to get power over here to the breadboard. So that's all I've done, is just jumpered over a red and a black wire over to this common strip that's down here along the edge. And they're already marked as positive and negative. And the red is positive, so I've used a red jumper. And I've set that up. Now what I want to do is I want to hook up a couple of LEDs. So I have a couple of LEDs here. So I have a red LED. And I have a green LED, just so we can tell the difference between the two. So I'm going to plug those into my board here. If we notice on here, something you always want to look for whenever you're looking at these things, and let's see, that's easier to show over top of the Arduino board, is that we actually have one lead is longer than the other. The longer lead is the positive lead on an LED. So on this LED here, I'm going to put my positive lead. And what I'm going to do is I'm going to make my life easy, and I'm going to put my common lead somewhere else. So I'm just going to take my positive lead and run it out to there like that, and there's my red. I'm going to take my green, and I'm going to do the same kind of thing and connect it across. My hands will be out of the way in a moment. And we can see we've hooked up a red and a green LED. We need a couple of resistors with these because they don't work on 5 volts directly. So what I have here is I have a 220 ohm resistor. Now the beauty with these little resistors, and we're working with Arduinos, is that we have a pretty wide range of voltages we can use. So, or resistance values we can use. I have found in the past that anything from about 220 to about 560 ohms works just fine. And you can even push it up if you're getting into blue LEDs because they're really bright. You can actually go and push it all the way up to about 1K, 1,000 ohms. And these are these are 8th watt or 1/16th watt resistors. They're very small because the current you're going to do is reasonably small on these things. We're talking they're going to draw between 5 and 20 milliamps depending on the resistor and depending on the LED style. Now I need to connect these to a couple of spots, so I'm going to go to pins 12 and 13. So I'm just going to lean over the board here so I can see where I'm plugging it in, and it looks like that's in 13. That's in 12. And I'll just take these and I'll plug these into where the resistors are. And hopefully I don't block too much view of those LEDs. If it does, we'll move them, but I think we can see them. So that's all I've done so far. This is a very basic circuit. Basically from pin 12 and pin 13, I've come to the board, I go through a 220 ohm resistor to the LED, the positive lead of the LED, and then to ground. And that's really all I've done. So we've made it very simple. Nothing more than that. Nice, simple red and green. Now, we have to set those up in the software, though, to use them. So there's going to be a couple things I'm going to do. So the first thing I'm going to do is I'm going to come into my software here, and I'm going to add in a couple of new variables that I created. So I'm going to create one called integer, and I'm going to call it LED, and the top one there is red, so we're going to call it LED red. In fact, I'll make the just normal programming habits is that we start each word with a capital, except the first word. So it's, and don't leave any spaces. So LED, capital R, ED for red. And I'm going to say that is going to be equal to, and I'm going to give it a pin number. And this is where I might, oh, this is, everything's going to work fine here. So I'm going to go to equals, and I'm going to say that's equal to pin 12. Because I'm using, did I use 12 and 13? I don't want to use 13. Let me go to 11 and 12. That's my fault. The reason I'm not using 13 is that by default, 13 is the little LED that's up here in the corner of the board, and we don't, or on the board itself, and we don't want to use that one. So I'm going to stay away from that. So I'm going to use 11 and 12. So I'm going to make my red LED, since it's closest to the top, I'm going to make that a 12. And don't forget, when you're writing Arduino code, to throw the semicolon in at the end. It gives you a hard time if you don't put those semicolons in. Trust me, I've done that lots of times. Now we're going to set up the other LED, and we're going to call it LED, and we're going to make this one green. And I'm using real words because real words just make it easy to find later as you're doing things. You could make these really short, and you could call it L1 and L2 if you really wanted to, but I like a little bit bigger names just because it's easier to work with from a programming standpoint. So that's what we've done. We've created two names now, one for the red LED and one for the green LED. So that's the first thing we've done. Now there's going to be a couple of more things we need to do here, and what we need to do is we want to set these two pins preferably now as outputs, because we want to use these two to drive LEDs. We want to set them up as outputs. Now, we don't necessarily have to do that with Arduino, but it's a good habit to get into. So we're going to put this in the setup area. So I'm just going to move down here to the setup area, and I'm just going to add those two pin modes. And that's what they call it in Arduino. It's called pin mode, bracket, and then we're just going to use LED red. So just using the name that we created above, comma, and then all in capitals, we're going to put in the word output and finish that off. Now, we'll notice a couple of things that have happened here. First of all, we have a word that's kind of gone an orangey color here. This is a predefined word that's within the Arduino language. So that is a word that it knows, and it knows what to do with that. It means something to the Arduino language. The other output here, it's gone this greenish, almost a cyan type color, and that's because it's also a recognized command word. So we've given it an object called pin mode, we've given it something to do, we've given it a name so it knows where to reference it, and then we've given it a command of output. So it's going to set that pin as an output pin. And we're just going to do the exact same thing for the other LED, just to be consistent. So this will be green. This is going to be marked out as output, bracket, and then semicolon. Now, I could have just as easily written the 12 and the 11 right into those two spots there, but the advantage of this is if I change my mind and I want to move it to another pin later, all I have to do is change it here, and anywhere it's referenced in the program, because I'm using the name, will do that. Now, I want to know if these are working or not. So there's going to be a couple little things I'm going to do here really quick. What that is I'm going to make the lights blink one at a time. So I'm going to start by using another predefined word that's in here. So this is going to be digital write. And what that's going to do, it's going to set the output device. So I'm going to say here, and I'm going to go LED red. And I'm going to make the red LED come on. And in programming terms, they refer to it as logical high. And so we're going to use the word high. Now, high just means take it and set it to the full voltage of that pin, which in the Arduino's case is 5 volts. So we've gone LED high, and they're going to start off, we think. So I'm also going to, just to make sure, I'm going to go digital write, and I'm going to say LED green, and I'm going to set it to low because I don't want it to be on yet. So what I've done is I've turned around and I've put the light on, red. I've turned it on. I've taken the green LED and made sure it was turned off. And then I'm going to put in a small delay here. And delay is another keyword. And I'm going to give it a time in milliseconds. And I'm just going to say do it for a half a second. And it's going to do that. It's going to pause at this point in the program while it's doing its setup. Very often when you see electronics start up, you see it go through a boot sequence when it first starts up. This is all this is. This is part of the boot sequence I'm creating. Now I'm going to turn around here and I'm going to go digital write, and I'm basically going to take that red LED and turn it off. So LED red. I'm going to set it now to low. And then I'm going to go in here and I'm going to go digital write. And I'm going to take the other LED, green, and I'm going to set it to high. And you can tell I've typed this once or twice. And I'm going to add another delay of 500 milliseconds because we want to stop for that half a second. And then the last thing we're going to do is we're going to take it and we're going to say we want to turn that green LED back off again. So we're going to do one more digital write. And we're just going to go to LED green. And we're going to make that low. And that just gives us a common starting ground. Now I don't need a delay after this because as soon as it's done here, it can go on with the rest of the program and continue doing with whatever I want it to do. I've also turned around and I've just created one light on, then the other light on, and then they're both off. And we can test this. We don't even have to go any further at this point. I'm going to hit verify just to make sure that my code is right. If it doesn't like something I've typed or I've missed something, it would come up and tell me. But it looks like it's all okay. So I'm going to now upload this. And very quickly, we're going to actually be able to see the two LEDs on here flash. So we're going to do that, and let's see what happens here. And we should be able to see that when it downloads. And it says uploading the board. Uh-oh, that's taking way too long. Has it died on me? Yeah, it could be. These are lovely computers. I don't like that. Uh-oh, and it's going to go through and it's going to do some more checks. We didn't lose the COM port. We still say Arduino Uno. According to this, it should still be connected. I might have to unplug it and plug it back in again. I'm going to try that because it's taking way, way too long. And Windows just did its little beeping thing. And we may have to wait for this to fail now. I'm hoping that it doesn't take too long. You gotta love live presentations when this stuff happens. This is the way it goes. I didn't like port name 10. There's a little diagnostic information down here at the bottom of it. So I'm not sure why this decided it didn't want to work anymore. But they do have a habit of doing that from time to time. You gotta love it when things like this happen. Looks like I connected everything proper on the board. I still see a light on the board for power. So it's telling me that it has a connection. In fact, this little light way down here is on, that little green LED. I don't know how well you probably can't see that very well. But it's telling me it's on, but it's not happy. So what I'm going to do is I'm going to close that window, which we're going to disappear here in a moment. Let me get rid of this window. And I'm going to open up a new sketch. In fact, I'm going to open up this file again. And just give me a moment here, and I'll see if I can place it on the screen roughly where the other one was. Okay, so if we do that, that looks like actually, and bring that in right about there. That's pretty close. So this is all in here. Again, let's just check our connections to make sure we are connected. That says it Uno. That says it's, oh, we got 2 instances now of the board. Never like that happening. And we're not going to install that board that it asked me for. That board already exists. Oh, live presentations. Aren't they fun? Let's still compile. Let's make sure it's still compiling. And it is. It's happy. I'm going to go up here. Still says I've got 2 versions of Uno. I don't like that. Let me just pick another board here for a moment. And go back to the Uno. So which one of these 2 it is, I don't know. Let's try uploading. And it says it's done. So we actually missed it here. Let's watch that again. And I'm going to upload it again to restart it. And you'll be able to see the 2 lights down here. There's the red and then the green. So it did work. So who knows why that happens on Arduino. It just didn't like the board for a moment, but it's working now, so we're going to continue on. Whew! Got by that point. You know, like I say, you got to love these live presentations. So the first thing we've done is we've hooked up these LEDs. We've hooked up some instructions now to make it flash. And we're going to add one more thing here. And one thing that we're going to have in here that we're going to use at some point is I want to get feedback from this board, what's happening while it's running. So I'm going to go in here and I'm just going to add a new line here, and I'm going to grab one and I'm going to call it serial.begin. And I'm just going to set it for 9600, which is kind of a default baud rate. And that's exactly what it is. If we're talking baud rates, that's a pretty slow baud rate, but it works fine with this. And what it's going to do, it's going to turn it on, and it's going to turn on the monitor feature so that I can actually open up a screen and see feedback. And one of the things I'm going to put in here in the feedback is I'm going to add a little comment down here, and because of that I'm going to put in serial.print, and I'm going to put ln for a line return, and I'm just going to put a quote in a message here in quotes that says setup complete. And I'm going to show you where that pops up in here, because we're going to use that as a reference for our sensors when we're testing them. So there it is there. So it now has a new file. I'm going to go ahead and upload that. And it should upload fine. Compiling. It's uploading. It's actually talking in the background, although we don't see it. But there's a little button up here in the top right-hand corner of the window. And I'm going to open it up, and I'm going to click on it, and it says Serial Monitor. And I'm going to show you what happens with that, because I'm going to show you... Whoop. Let me look at that again. Here we go. And I'm just going to put that over here to the side. And with that there, you should be able to see it. And it actually put in the comment. It says setup complete. So it actually wrote that in there. If we want to see that go in there, I'm going to hit upload. I'm going to open that up. And we're going to see it's going to type in there. And it just replaced that message. Oh, there it is there. So once the light's finished, it put up the new message saying setup complete. So that works really well for us, and that gives us some feedback. And we're going to utilize that when we add the sensor. So that's going to be the next thing we're going to do. So let's get back into the programming screen here. We want to get into the loop, but one of the things we're going to need is we're going to need to hook up one of those sensors. So I'm going to start with this LDR. So I'm actually going to take the LDR, and I have a resistor here, and I have a 10K resistor. You can actually vary the value on this a little bit. So I am going to connect it across 2 pin spots on here, whichever 2 it likes. There we go. I'm going to take the resistor, and I'm going to supply it with a return line going to the resistor. There's a couple of ways you can do this. And what I need to do is I need to supply this with a little bit of power. So that's what we're going to do, is we're going to supply this with some voltage going to it. So we're going to go from the plus lead. And we're going to pick up power to the LDR. And then once we come back on the resistor, and then we're going to hook up one wire over here. We're going to take a wire and we're going to bring it back. And I'm just going to grab this white wire, and between the LDR and the resistor, I'm going to take that wire and I'm going to run it all the way over here to A0. A0 is an analog input on the board, on the Arduino itself. It's set up to bring in an analog signal. So what happens here is if it brings in a full voltage value of 5 volts, it's going to read 1024 if it sees the full voltage. If it sees nothing but the ground connection, we are going to see 0. So we're going to see what this reads to us. So we have to set up some programming here. So this is what we're going to do. So the first thing I'm going to do is I'm going to scroll back up here where I created the 2 LEDs, and I'm going to create a connection for, I have to create an initial value for this sensor. So I'm just going to come in here and I'm going to go sensor LDR, since that's the one we're going to be using, and we're going to say equal to 0, but I have to give it a data type. So we're going to give it the same data type as the other ones. We're just going to make it an integer. And what we're going to do is we want a value from 0 to 123 coming back. So I'm just giving it an initial value of 0 just for the first time through. Then what we're going to do is we're going to put it into our program down here, and we're going to put it into our loop. So this is the part that you want to run repeatedly. And I can clean this up and get rid of all the extra lines and everything else later. But I'm going to start by putting it in here, and I'm going to put it in void loop. I have to read the value from this LDR. So for this, I'm just going to type in sensor LDR. I'm going to use its name, and I want to get it the value. And what I want to do is I want to take a reading. So I'm going to go analog instead of digital, because this isn't just an on or off state. We're actually bringing back a variable. So we're going to go analog. Let me get a space in there because I like the spaces in there. And I'm going to go analog, and instead of writing, I'm going to read. So now I'm going to read in the value. And basically on here, I can actually put in the value, the pin number there, and I'm going to add in the pin A0 because it's analog pin 0. So it's A0. And it'll know what that is because it's been predefined in the Arduino board. So it's going to read in that value. And then what I want to do is I want to print it in my serial monitor so I can see it. So that's what I'm going to do, is I'm going to come down here to the next line and I'm going to use the serial print command. Now this time I'm not using a carriage return because I want multiple things on one line. So what I'm going to do in here is I'm going to go serial print and I'm going to put in a message that says LDR value. And I'm just going to make it nice and neat. I'm going to put in the colon and then a space and close off that. And then what I want to put on the next line is I'm going to go serial.print. And this one I will use the line return because I want to have a carriage return after this to move down to the next line in the monitor after it prints this. And I'm going to put in the value of sensor LDR in this location. So by not putting it in quotes, and I'm using that name that I saved the value to, it's actually going to write a number in here. So I'm going to do that. Now, we don't want this to happen too fast. If this happens too fast, what happens is we'll never see anything else happen in here. So I'm just going to add a delay in here, and I'm going to do this once a second. So I'm going to put in a value of 1,000, which is 1 second. So every second, I'm going to get a new value in from the LDR. And we're going to see how that works for us. So everything looks good here. Let me verify. It should be fine. If not, it'll let me know. It says it's okay. So let's go ahead and do that. I've gone back to this screen here. We're going to see the value come in. There's the blinking. We saw setup. And now we have an LDR value. And there you can see we have a value of 545, 547. It's going to bounce around a bit. And then what happens is if I cover it up, look at that value drop. But it doesn't drop to 0. It only drops partway down. And I'm down to around 150, 160. So that's not bad. So I can actually see a fair bit of difference there. It's got some light coming on it. In fact, if I move this around a little bit, it'll see different amount of light. And I'm going to show you something here, and it's probably going to blow out on the screen a little bit. But I'm going to take a flashlight that's actually very bright, and I'm going to shine it onto the LDR. And you're going to see that value jump way up near the top. So it's right up near the top reading of 1023. It's not quite there, but it's pretty close. And if I move the light source away, it drops back down to an independent value. Now, that is both good and bad. The good is it saw the difference in the value. The thing is we're about mid-range right now. So we have to keep that in mind when we're actually going to do something with this later on, is that we're seeing about mid-range. And the problem with this is it gets a little cloudy, or somebody blocks a shadow in here. If I shadow that a little bit, we can see the value will drop slightly. If we cover it up really close, we see the value drops. If we get close enough, we got to be over it, we can see the value drops considerably. So it's not an exact science, and it has to deal with the ambient light in the room. So the ambient light is going to make a difference to this thing. It's going to affect how our values come in. So that's the first thing that we see here. We see that this works, and this is how it works for us. But it does work, and that's the key. We are getting different readings for different things. So let's have a look at some of the other sensors that are available to us. I talked about the infrared sensors, the little independent ones that I have here. So what I'm going to do is I'm going to hook up these little independent sensors here. So I'm going to take one set and I'm going to put it way over here. That's my emitter. And where did my little detector go? There it is. And I'm going to put in my detector. And with any luck, I'm actually going to get these two facing across from each other. But I do want to note which one's the long pin on the emitter. The emitter's on that side, so that's going to be the positive lead. So that goes there. I left a couple of spaces. So there I am there. I've created a basic circuit. Now what we're going to do is we're going to work with a couple of spots here. So first thing is we have an emitter. Well, this has got the same issue that we had before with power. So I'm going to put in a resistor here on the positive lead. Mind my fingers here while I'm trying to make this thing happy. Come on, breadboard, don't be so stubborn. There we go. So now we have a spot there. I'm going to take a red jumper and I'm going to jumper it from the positive back to the positive rail back here somewhere. I'm going to take a negative and I'm going to jump it from negative. Well, we're going to move it over this way because we're getting kind of crowded in here. And this is what happens when you're playing with these things. Is I'm going to come over here and I've got to add that to the negative pin there. So what's happening now is I am now putting out an infrared signal. So very easily I'm just getting a nice infrared light going there. Now we want to be able to read it. So to read that, we're going to do the same thing we did before. Now you hook up these backwards compared to the other boards. So what happens here is I'm actually going to take in and I'm going to take my resistor and I'm going to run one end of it to power, just like we did before. So this is the long lead on this side. Long lead is over here, so we're actually going to run power to the short lead on this because this is a detector. So we're going to make some room here. I want to run from power to power. So I'm actually got some power coming in there. I need a ground wire coming back, which I seem to be short of. So we'll just grab some extra jumpers here. I probably knocked it on the floor or something, and I'm not going to go look for it. And I'm going to go from the other side. And this resistor actually has to go to power. And this should go to ground. And then I need to have a lead that's going to take it from that same as the ground pin. And what I want to see is I'm going to take this and I'm going to run that to analog 2. Analog 1 actually, because we used analog 0 for the regular sensor. So the board's starting to look a little more crowded. The value for the resistor is for the receiver part. I used a 10K, same as the LDR. For the emitter, I'm still using the same as a 220 because it's just an LED. So it works the same. Even though I can't see the light, you're going to use between a 220 and a 560 ohm resistor for the emitter. So you're still going to do it the same as you would for a regular LED. It's non-visible light. That's the only difference. So we're going to start adding in some of this stuff here. So we're way back up here where I added sensor 0 for the LDR. I'm now going to add an integer value for sensor infrared. And I'm going to make that equal to 0 as well. Hopefully that answered your question, Walter, about the resistors. You know, we can always you can always ask questions later and we can get you more values and we can see what happens here. So there's our infrared. So it's basically the same setup. It's just we have to set up a transmitting, which is an emitter, and that's just an infrared source and a detector. Now I will tell you one thing about the infrareds when you're using them. They all deal with frequencies in nanometers. And typically these are around, I'm trying to remember whether these are 820, but I think they're like 820, 810 nanometers. There are different values. The best way that they work is if the emitter and the detector are tuned at the same nanometer setting. So usually if I buy them as a pair. I buy an 820 nanometer emitter and an 820 nanometer detector. And that way I'll get the best signal from it. Will it work if you have one that's slightly different? Sure it will. It just won't be as sensitive to the values because it's kind of a peak that they're looking for. So hopefully that helps too. We can get into more technical detail about that if we really need to. So here I've done everything else I've done here. There's no difference because I never set up anything for my LED, for my LDR. So now what I'm going to do is I'm going to go down here and I'm going to add this in here. I'm just going to come down to the next line. I'm going to throw in sensor IR. And I'm going to say that that's equal to analog read. And this time it's going to be on pin A1. Now I'm not sure what values I'm going to get, and I can change this around a little bit by changing where my sensor pin goes, whether it's on the positive lead or the ground pin lead. In fact, actually it should be on the positive lead, thinking about that, because that's where I'm going to see the difference. And let's just move that over to there. As you can see, it gets kind of crowded in there in the board, but it'll work. It'll still work for what we want. And then I'm going to add in my serial prints for these too. So I'm going to go serial.print, and I'm going to put in its message so I know which one this is. So this is my IR value. And we're going to say here the same type of thing, and bracket and semicolon. And we're going to come down here and we're going to bring that value serial.print ln, and we're going to put in sensor IR, and we're going to put that in. So this is also going to happen on the 1 second interval. If everything's right, when I tell it to verify, it'll be happy. We'll see. It looks like it. So let's go ahead and upload that and click on the monitor. We'll see it goes through. We should see that setup complete come by in a moment. There it is. And there's our values. And we can see right now with the infrared, we're seeing it on 117. So it's relatively a low signal. If I put my finger between them, oop, I'm still seeing a low signal. So I may not be connected where I want to be, which is possible. I may have this all backwards. This is the fun of working with this stuff, is trying to remember which way it works. Because I should have a much higher signal than that. It should be changing, and it's not. It's staying around 116. So I'm going to have to troubleshoot this slightly here. And about the only thing that I can do is probably hook up the power wrong or something like that, or miss a pin. So let me reverse a couple of things here. I'm going to go there. I'm going to ground that one. Now I got a high value. Oh, and it even went higher. There it goes. So when I block it, when we line them up, we get 708. Now, let me see if I can find something small to put in between there. I have a nice little card here, so I can see 708. And I can see the rise, and it went up to 1014. And it's reading at 710 when it's actually interfering. If you actually get them lined up perfect, you can change these little values slightly. But the big deal here is the fact that if we line up, and that's what's critical with these, since you're supplying the light source with this, you have to keep in mind that you're going to see a different value in there. So there I'm at nice 748. When something comes in here and blocks it, I can see that it jumped up to 1000. So that seemed to work fine for me. So that actually works really well. I remove the blockage, and it drops down, and it's below 800. So I actually have them lined up not too bad at the moment. So we can actually see how that works, and we can actually see those values coming in there. Now there's a possibility I got my resistors mixed up and I crossed them around, and I switched my 10K and my 220, but I think I should be okay. If I did mix it up, I mixed it up, but it doesn't really matter that much. We have a fair bit of play in these things. So again, I will block it, and we'll see that that rises. When we remove the blockage, it drops down. So we actually have a positive detection. So we can actually utilize those values to our favor. So that works. So now, how do we use these in a circuit? Oh, and the flashlight. Let's get the flashlight in here. We'll see that I can shine the flashlight in here. My LDR value is changing, but my RR value, my infrared, does not change at all. In fact, I'm shining right on the detector, but if I block that signal, we'll still see it rises. So it's not affected at all by ambient light. And that's where you get the advantage of infrared. Infrared doesn't care if the room lights are turned on, if you're on a train layout. It doesn't care if it goes into a shadow or somebody puts their hand somewhere else. It's strictly by the infrared value. So it actually eliminates all that lighting issues that we normally have, which is really good. And I moved my board a little bit, so we'll move that down a little bit. But I think you could see everything I was doing. Just check it one more time. And we could see there, and those values are changing. So that's really nice. So it does work the way we want it. In the meantime, my original one is also working. It's dropping down to a low value when I take my finger off the resistor. So using that serial monitor, we're able to see the values that we're getting. So let's try to utilize this now. So I'm just going to leave that and move that out of the way. What I want to do is I want to turn on an LED. So I'm going to come down here after this delay. In fact, I'll do it before the delay. I'm just going to create another block of code in here. And basically what I'm going to do here is now I'm going to tell you what to do if something happens. So we're going to create what we refer to as an if statement. And inside an if statement, it's broken into some basic parts. So the first thing that we have to do is we have to put in the argument or the condition that we're looking for. So in this case, I'm going to use sensor 1. So my first sensor was sensor LDR. So we're going to take that value for sensor LDR. Now, when we looked at that, if we go back into here, we can see that that value is sitting around 513. When I cover it up, it drops down to 84. So all I'm going to do is I'm going to say, hey, if the sensor is less than, and I just use a standard less than symbol, less than 250. I want it to do something. So I'm going to put in my close bracket there, and then I'm going to start it with a brace. Brace is just the squiggly bracket that we have here, and I'm going to hit enter. When I do, it drops me down to the next line, and it indents me slightly. So what I'm going to do here is I'm going to do a digital write, and I'm going to have it turn on and off the first LED. So I'm going to have it go right, and I'm going to choose the LED, and the first one, the one close up the top is the red one, so we're going to use LED red. And what we're going to do is we're going to tell it to go high. We're going to turn that light on whenever it's blocked. And from there, what we're going to do is we're going to move down to the next line, hit a space, and then we're going to put in an else command. We're going to put in another brace, opening brace. We're going to come down, and we're going to put in, hey, if it's, in other words, if it's below 250, turn on the light. If it's 250 or higher, I want to turn the light off. So I'm going to choose here, I'm going to use digital right. And I'm just going to choose LED red. And I'm going to go low. So turn it off if there's nothing blocking the way. And that's all I'm doing. This is all I've done to the program now is I've added this next little step. So what we're going to do is we're going to upload this, which is going to start by verifying right away. And by the way, every time you hit verify or upload, it is resaving your file on your computer. That's why we wanted to use that save as at the beginning. So in our digital monitor, we can see we have our values here. If I block the light on that LDR, we can see the red LED has illuminated. If I take it off, watch the LED up here. I block it, the LED becomes true. We'll move that wire over a bit if that helps. Or is it? There we go. Move both of those. So we can see that this happens. Now there is a 1 second pause between reading. You can do this much shorter time, but I've done this just so we can see it. and we can see that that light works. It does exactly what we wanted it to do. Well, we can do something similar for the other one. We know the other one's sitting at around, the IR value is around 750. What we're going to do is we're going to look for it to go above 850. So we're going to create another condition here. We're going to create a new if statement. So this is going to be if, and in this case it is sensor IR is greater than 850. And what we want it to do is we want it to do something else. We want to go brace, and this could be something, hey, keep traveling in while you see a green light until it turns off. So you could tell it for that if you're bringing a train into an area. So in this case here, we're going to say digital right, and we're going to choose LED green. And we're going to tell it to go low when it's greater than 850. In other words, turn out the light when something is blocking the beam. So that's the condition I'm going to be looking for. And again, I'll put another else statement in here because I need to be able to turn that light back on. And that's what I'm going to do here is I'm going to include a digital right. And I'm going to choose LED green again. And this time I'm going to tell it to go high. And that's going to be it. That's my whole statement. So there's my red LED is affected by the LDR. My green LED is going to be affected by the infrared. So I'm going to go ahead and save that. In fact, oh, it didn't like something here. What didn't it like? Here's a good chance for us to see what it did. Oh, expected semicolon before. And it's missing one. It says from here, LED green, high, low, before the closing bracket. Where did I miss it? Let's see here. Let's just validate again and make sure that compiles. No, it's being consistent. I don't have it in that one. We'll add a line in there. Uh-oh. Look at this. Look what I did here. Commas. It's picky. Yeah, bracket in front of the, it's missing the regular bracket. Not a curly bracket, not a semicolon. So what's happening here, see how easy these things get mixed up? This is typos. Typos will kill you in programming. All right, it's done compiling, so let's try this again. So we're going to go in here. We're going to see our two lights blink. Now our green light is on. Our green light is on because the value is, it's less than 850. And not greater than 850. So it's going to be on, which is the low, which is the state. If I block that, it shuts off. So now that my value is higher, it's going to go and it's going to turn it to low. So what happens here is the way we look at this, when we're looking at these statements, the if statements, this is the condition. The immediate code right after this is what I'm going to do if this condition is true. And it's a logical state. It's looking for logical state true. Then the else is going to say do this if the logical state answer up here was false. So right now, is it above 850? No, it's not. So it's false. So the green LED on our board is on. And that's doing exactly what we anticipated it would do. At the same time, if I block this one, my red LED still comes on. So it's working. We watch it there and it shuts off. We can see that happening. My green one, if it gets blocked, I can put that in there. It's going to stay blocked. And I can block this one, and it still works independent. So they're totally 100% independent from each other. So now we can have multiple signals on here. So this all works really, really well. Now, I showed you all this stuff here. I've walked you through it. This is basically how the difference works between infrared and LDRs. And they both do the same thing. You can have slightly different values coming back from them and slightly different conditions that happen. But you just create the instructions to fit whatever numbers you want to use. Now I'm going to show you one other quick device here. And I'm going to put it down here because I'm going to try and get this in a spot where we can show this. I'm going to see it, how it fits. Oh, it does fit just in the screen. So it's right there. This one's a little bit different. This is a pre-mounted. And I have this as a sample because I've used this a few times. We want them further apart. Alignment is critical when you're talking infrared. And what we're gonna use here is we're actually going to take this, and this one has pre-colored wires connected to everything. So connected to the emitter. This is the emitter at this end. This only has two wires. This has a red and a black. It already has its own built-in resistor the right size. The other end here is the detector end. The detector has a third wire, a white wire, but it also has a red and a black because it requires power. The white wire is nothing more than the feedback coming back in. So we're going to show you what happens here. So I'm going to take this, and I'm going to take this here, and let me get my white wire out of the way. There's my red and my black. And what I'm going to do is I'm going to connect the red one to the positive down here. I'm going to connect the black to the negative lead down there. And I've just used jumpers to, let's get everything arranged. There we go. So it's all set up there. Then what I'm going to do with this other wire, I've got this other wire, the white wire, it's attached to the green alligator clip. I'm going to take it and I'm going to run it to a digital input. I'm actually going to run it to pin 7. I'm going to run it a little bit different. Because this is a predefined system, and this will give me a very good signal, I can actually take this and I could do it two ways. One, I could run it in as an analog signal like we've been doing. In fact, if I were to remove the wire here that signals from the existing infrareds, let me just take that one off and move it out of the way, and I'll take this green wire and I'll hook it up where the other one was. And we'll actually see we get in a value, and it's a very low value right now. If I block it, it drops down to virtually 0. When I bring it back up, it's something higher than 0. So it actually does give me a value between those two. The infrared value, actually that looked like it was a little better, so maybe there was something blocking it. It could be bumped slightly. But the whole thing is it drops down to 0 the way that that sensor is hooked up. So it does give me the ability to use it just the way it is and use the analog input. But we don't always have analog inputs to play with. So what we're going to do is I'm going to take this signal, I'm going to put the orange wire back on for the other LDR. Let it work the way it was working, and I'm going to run this back to digital pin 7. So I'm going to run digital pin 7 as an input. So I'm going to make a couple changes to my program. And one thing I'm going to do here in my setup, I created 2 output pins. Well, I'm going to come in here and I need to create an input pin for this pin 7. So what I'm going to do is I'm going to type it in here as pin mode. And I'm going to go in here. We didn't give this a name yet. So instead of LED red pin, I'm going to call it just IR pin. I'm going to use that name, IR pin. So that's my new infrared pin. I just want to give it a different name than the other ones. And then what I'm going to say is I'm going to call it input. But I'm going to use the underscore, and I'm going to use something called pull up. Pull up applies the full voltage to that pin, and then what it's doing is looking to ground the infrared signal. So what I'm going to say here is this is going to look for the ground. And I got to put the semicolon here on the end. So there we are here. Now I'm going to have to define this name called IR pin. So where we defined all our other pins up here, let me just go in here and I'm going to go internal and I'm going to go IR pin. And I've hooked it up to pin 7, so that's going to equal pin 7. And then what I'm going to have to do is I'm going to have to give it another value because I'm going to be looking for a digital value. I'm going to have to read that pin. So I got to set that up something. So I'm going to set up another integer that's going to say sensor new IR. Since I put IR in small letters up top, I'm going to put new IR in small print down there. And I'm just going to make it equal to 0. It's just a name. So there we go now. Now I'm going to come all the way down here to where I was reading all my other values. Let's see what I get for this one. So very quickly, I'm just going to go sensor new IR. And I'm going to do equals. And then this time I'm reading the digital value. Digital read. Digital read. And what we're going to do in here, we have to put in the pin, and it's just called IR pin. So there it gets our reading in. And now what we need to do is we need to do the same thing with the serial prints, because we want to see what we get out of it. So serial print. And this one's going to be the quote, and this is the new IR value. And the next line is going to be actually displaying the data. And that was just called sensor new IR. And if I did this correctly, it should come up and it should give me now a new value for that. Let's just verify that in case I gave any typo errors. It's easy to do. It's done compiling. Let's upload that and see what the difference is. So we're going to upload that. We're going to wait for it to boot up. And there it is. It's showing me a value of 1. So 1, there's no occupancy right now. If I block this, it dropped to a 0, a value of 0. So it gives me a 1 or a 0 state directly on the digital pin now. So even though it's an analog signal, I can use it. And the reason why is very simple. What's happening is here is in one state I'm reading a voltage that's near full voltage. And then what happens is anything that's close to being full voltage is considered a 1. Anytime you ground that pin and the voltage drops close to 0, doesn't have to be at 0. It says it's a 0 value. So it goes false, the input pin. So because of that, I can actually take an analog signal, because I'm looking for a wide range now, and it will always be a wide range when I do it this way. It will actually give me a 1 or a 0. So I can actually improve my logic. Now, there's a couple of things I can do with that with the other ones too, but it doesn't work as well. And it's the same principle, is I can use high and low for any of these analog values, but the problem is I don't have enough range usually to get to 1 and 0, which I do with the pre-mounted versions, because they have the right resistors in them for those, the emitter and the detector, and they're bang on to what they need to be, so our readings are much, much better. Those are actually pretty cheap sets, and the fact that they're actually mounted in a pre-mounted case makes them easy to mount on your layout. So that's just a third different way of doing it. So as you can see, we've covered 3 parts now with these detectors. We've covered in an LDR, which are nice and cheap. You can buy them in bulk. You can buy infrared emitters and detectors. You can also buy them in bulk, and we've seen that they work, and they work well because they are not affected by ambient light. And the third thing we've done is we've used a pair of infrared detectors that were bought in a package. These ones are available online. They're also available at some of the suppliers. My particular ones came from Adafruit, but you could buy them at a number of places. And the thing is that they're all pre-wired. They already have the right resistors in them. It's a simple hookup. Power and ground to both of them, and then a signal wire coming back, which now I can use digitally, which gives me a fixed hard value. And again, I don't have to worry about ambient light. So I hope this has answered, or at least given you some food to thought, to think about as far as infrared detectors go. and how light dependent resistors go being used as circuits. And I hope you have enjoyed this video. You can leave your comments. You can let me know. Walter, I hope you enjoyed it. You were the guy who watched this the whole way through, which is really handy. Thanks for the comments during the stream. Always come in handy. Typos are always a killer whenever you're doing code. So always go back and remember to check out your code. It's very important. And again, thank you very much. If you enjoyed this, I'm going to be doing more of these talks, microcontrollers with me, with kingernorth. And they'll be on my YouTube channel. If you want to get notices about them, subscribe to my Twitter channel if you use Twitter. And you can do that. And on the closing statement here will be my Twitter handle, which is just @kingernorth. And my YouTube channel is kingernorth, based on YouTube. You can just search for kingernorth from there, or go to youtube.com/kingernorth. Both work. Again, thanks. And hopefully we'll have more topics. If you have ideas for topics, send me a message in Twitter. Send me post a message here on YouTube. If you know me, send me an email. I'll take that too, or call me. And by all means, let's play around with more electronics with microcontrollers, using microcontrollers for our model railroading or for any other aspect of any hobby. You know, robotics, whatever it is. Thank you very much, and have a good day.